There are also big phylogenetic groups of organisms where we don't have any representatives in culture. Now, how do we know about these? We're going to talk in some detail later about phylogenetic characterization of environmental samples. But what it amounts to is you isolate DNA from an environmental sample, you either amplify or directly sequence ribosomal sequences right out of that mixture of DNA. So there's no cultivation required. And you see what you get, right? And in the old-fashioned way, you get maybe a dozen sequences out of the environment. These days, you might get 500,000. And so you get a pretty good representation of what is out there in an environment without the need to cultivate them. And in many cases, those organisms are not cultivatable. OP11 is one such group. This shows up all the time in environmental samples, members of this group. In some cases, 10 or 20% of the ribosomal sequences in a soil sample can be in this group. And to this day, not one of these organisms has been cultivated. And so they need something, but we don't know what. This thing was originally isolated from this place, Obsidian Pool. The first sequence of this was from a sample taken right here. But it turns out to be everywhere. And this is where the name OP11, this was the 11th sequence from Obsidian Pool. And then there are quite literally thousands of phyla of bacteria that look like this, where you've got 2 or 3 or 4 sequences from the environment, and that's all. And you don't know anything else about them. Theoretically, of course, you could have any number of single sequences that would be this way. But a single sequence is problematic, right? You don't know if it's a PCR artifact or some kind of weird defect in what you've done somehow. And so generally speaking, you've got to have 2 independently derived sequences falling together to be considered a phylum like this. These came from SRB. I don't remember what that site is. The same site, but in 2 different experiments. Oh, here we go, Sulphur River in Yellowstone. So we don't know what these things are. Typically, these don't show up very much in phylogenetic analysis of environment, but in many cases, a lot of the diversity in an environment may be made up of these sequences. In other words, no single one represents a significant fraction of the population, but add them all up and they do represent a significant amount of the diversity in a population. And what they're doing, nobody knows.